Hi friend! Today we're going to design the printed circuit board for the Rat pedal. You know where we're going with this, so let's start up Eagle and get started. Okay, let's make our printed circuit board. First, we're going to generate the board from the schematic, and you'll see that there are a lot more components to deal with this time. The treble booster was simple in comparison. This is still a simple circuit, so we'll have no problem. First step, let's choose an enclosure. 125B, let's go with 1590B. We're going to set this in here. We could set it in here like this, and we could redraw the dimensions of the board to cut this part out. But let's just go simple this time. That'll be for another video, and we'll just put it in the space that it actually fits. So this part right here, this little sliver, will be unused, but that's not a great big deal. All right, let's shrink this board down to size. We'll put it just inside there. If you hold down the Alt key when you're adjusting this, you could get between the clicks. See, it's up here in this grid. Right here, it's 50 normally, 50 mils between where it snaps to grid, and if you hold down the Alt key, it's 5, so it's 10 times as granular. Granular? Okay. Which brings up another point. Let's turn that grid on so that when we place the potentiometers, all the switches and everything that needs to be lined up, it'll be a lot easier. All right. Do you remember how I mentioned that you could grab the names of a component instead of the component itself? It gets annoying. Here's a way to alleviate that problem. Go to the View menu, hit Selection Filter. These are all the items that you're allowed to select. So what we're going to do is hold down the Control key and deselect Attribute. Now when let me clear that out of there. Now when we grab something, you can only grab the component itself. All right, now we have 3 potentiometers. Let's get those placed first. What we're going to do is use as much space as we can without wasting any. Should I say, we're going to place this in there like that. Now, see, this isn't wasted space right here. We could put a resistor there because it'll be on the other side of the board from the potentiometers. What I like to do is grab the next potentiometer and make sure it's lined up. All right, is that lined up? It is. But this is not lined up. All right, this dimension line was a little bit off kilter. All right, now let's grab the last potentiometer. This is the tone potentiometer. See how there's not quite enough room if we wanted to go like this. They overlap. That is the dimension of the actual body of the potentiometer. So we could either put it here or we could flip it around and it'll be way out of the way. So let's do that. And there we go. That will also guarantee that there's enough space between the knobs themselves. Let's hit that rat's nest. See how things change when you do that? What I'm going to do now is place the components, and I'll be right back. Okay, looks like I got all the parts laid out in a somewhat logical manner. You'll notice that sometimes you'll run into a part that see, like right here, this one's right next to it. It's a short run, but that means this one has to be a long run. Just go with what's best and run your rat nest and go from there. We're going to move this up. Let me turn this one. We're going to move this border up. Okay. Now once we do this, we could spread, this is as small as we could get it, so we could go back in and spread the items out a little bit so there's more room to route traces, and I think I'm going to do that now. But first we're going to move this down. Put this all the way there. Oh, I got a little, see that little red mark right there? That means it's too close to the edge, but we have not yet loaded the design rules in from Osh Park. We're going to go here and load in the board. Now everything looks fine. We're not going to put our ground plane in yet. Let me do the, I'm going to spread things out. Another thing I did was I moved the jack connectors to the top. This is the input, this is the output. They're on the right side this time. We could either put the jacks on the sides or on the top. Top mounted jacks seem to save space on a pedal board, so that may be a good plan. All right, I'm going to spread these out just a little bit, but I'm going to leave the potentiometers and the switches where they are. I think I'm going to try to move these items down just because what's the point of wasting all this space up here? All right, let me try it. All right, got a little tiny bit smaller. Maybe save a few cents. Next thing we have to do is run the routes. Well, I spent about 3 hours trying to run the routes on this board, and it just didn't work out. I had the dimensions too small, and the components were packed too tightly for what I wanted to do. So I just started from scratch again. If you're doing a board and it's just not working out how you want, say you have your routes all put in here like this, and you're just not happy with how it's working out, you can use the rip up command. What this does is takes all your run routes and tears them out. It's just like when you're on a breadboard and it's just not working out how you want. You just grab all those wires and pull them out. So let's run a rip up. Hit yes, and you see how it takes that route out, and you hit rat's nest again, clears out the whole board. If you wanted to do an entire new layout from scratch, just go to your control panel, right click on that board and hit the delete command. Get rid of it altogether. Then you could regenerate it from the schematic. That's what I ended up doing, and this is what I came up with. Let me get rid of that top and bottom layer just so we can see how it's laid out. I made sure my potentiometers were in a good place. I got the switches and this potentiometer. All of these are in a row. I use the grid. I put the extra switches down at the bottom, and let me tell you, I really regret doing all these mods on this one. If you follow along and put all these in, find the ones you like and make a new one. With all these options, it's just too complex for what this circuit is. Regardless, we're going to now route this new board. Let me put these top and bottom layers back in. As you can see, I did do polygons on this. But what I did was I put one on the top and one on the bottom. That way, if there's ever a break in the ground plane, we can run a via through there and make sure everything's connected as it should be. All right, let me get started here. You know, when I tried to get that first board to work out, I even invoked the auto router. It's kind of a dirty word, I think. It works better than a lot of people say. But it takes part of the fun. Part of the layout makes this yours. You're just letting the computer run it. I don't do it. I'd suggest learning how to run routes first. And then if you have a difficult section after you get most of your routes done, try to hit that auto router, see if it could get the routes through that you couldn't figure out. And if it can't, it's time to just start again, like I did. All right, let me get these routes in. There you have it. Let's run all our checks. First we'll do the rat's nest. It says down here, nothing to do. Perfect. Now we're going to run our electrical rule check. 2 approved warnings. What those are, we have 2 approved warnings. Now what those are, right here you'll see. For some reason, every time you connect a voltage to the IC, at least this one, it gives you a warning that you've applied voltage to it, and you've also applied a ground to it, which is 100% normal. So I approve those 2 warnings, and we come back to here, and we're going to run our design rule check. This is going to check it against the Osh Park 2-layer design rules. We have 2 dimension errors. Aha! I'm going to have to reroute that one for the voltage. Looks like voltage. Let me see. Yes. Be right back. All right, nothing to do. Let's run this check again. We have our 2 approved errors or warnings. Board and schematic are consistent. Excellent. Well, let's see if we took care of that dimension error. No errors. Excellent. DRC, no errors. Excellent. All right. We are complete with this board, and we're going to submit it to OSH Park. Let's see how much this one costs. First thing to do is make sure you've saved your board. So if you don't save it after you complete it, you'll upload the wrong thing. I've done it. There it is. $17.80 for 3. Let's see what that comes out to. Less than $6 per board. What do you think of that? There's another YouTube channel I enjoy watching. That's the Guitologist. It's just fun to watch. I especially like his rants. He had one recently. It was kind of funny. He handles criticisms well, let's say that. He has a good head on his shoulders. He thinks things through. He likes a lot of interesting music. And he's not just based on guitar stuff. He shows you, you know, things he got at the flea market that he repairs. And he makes some interesting things. My favorite part's when he works on Marshall amps, though. Really get a lot out of it. So thanks to the guitologist. Maybe I'll see you sometime. All right, thanks for stopping by. I really appreciate it. Have a great day.